Laws of exponents and application. We are going to learn different laws of exponents and also do examples on each and every law. But first we need to know what is an exponent. So now a number can be represented as a to the power of n. So usually mathematicians says that this whole number here is called an exponent. And they say now this is going to be the base of the exponent, and then this is going to be the exponent of the exponent. So now I know what I've just said, it does not make sense. But now I'm just going to refer to the whole thing as a number. And then I'm going to say in a number, we have a base and an exponent so that we don't get confused. So the first law says what? It says that if you have any number raised to the power of 0, that number is going to be equivalent to 1. So let's say, for example, if you have 16 to the power of 0, without thinking or putting this in your calculator, you should know that the answer is 1 because the law says any number raised to the power of 0 is going to be 1. So, but now we can have a number like this, 16a to the power of 0. So, in this case, it is only a that is raised to the power of 0. So, the 16 will remain to be 16, but now a to the power of 0 will be equal to 1. So, now if you say 16 multiplied by 1, the answer will just be 16. So, that is how you will apply the first law. So now what does the second law say? The second law says that if you multiply numbers with the same base, you are going to keep the base the same and you're going to add the exponent. So now we have numbers that have the same base and we are multiplying them. So what we're going to do, we're going to say that we're going to keep the base the same and we're going to add the exponent. So now the exponent is m plus n. So that is what the second law says. So let us look at few examples. Let's say we have 11 to the power of 9x multiplying with 11 to the power of 2x. So we can see that the numbers that we multiply, they have the same base. So we are going to keep the base the same and we're going to add the exponents. So that's going to be 9x plus 2x. And this will just simplify to be 11, and then 9 plus 2 is going to be 11x. So that will be the answer to the problem. So let's say, for example, now we have 10 to the power of 6x multiplied with 10 to the power of negative 2x. So numbers have the same base and we are multiplying. So we're going to keep the base the same and we're going to add the exponent. So this is just going to be 6x plus negative 2x. So now 6x plus negative 2 is just going to give us what? 4x. And that will be the answer to that problem. So now, the third law, it says that if you have a number inside the bracket and then the bracket is raised to the exponent, that exponent outside will multiply with all the numbers in the brackets. Consider what is inside the bracket is a product. So now let's say we have a to the power of m all to the power of n. So now this law says that if you have a number inside the bracket, so this must be one number, or we can say one term. So remember, if we talk about one term, we just talk about any number that can be a product. For example, if you have m multiplied by n that is one number, it's one term. Okay? So inside the bracket, you can have just one term. So the law says what? It says that the exponent outside the bracket will multiply with the exponent of everything inside the bracket. So the answer to this is just going to be a, and then this exponent out will multiply with m. So we're going to have mn. But now this law also says if you have what? A number inside the bracket, which is, for example, m to the power of b multiplied by n. So this is just one number here. Okay? And then it is raised to the power of n. So the n outside will multiply with the exponents of everything inside. So now note this, if a number is without an exponent, the exponent is 1. So now we're going to say n will multiply with the exponent of m, and this is just going to be m bn. And then also n will multiply with the exponent of the other number on the product, and therefore we're going to have n to the power of n. And that will be the answer. So now let us look at a few examples of this law. Let's say we have 6c all to the power of 3. So remember, I said that if you just have a number without any exponent, this means the exponent is 1 here, and the exponent of c is also 1. So now this, what is outside the bracket, will multiply with the exponent of everything inside the bracket. So this is just going to be 6 to the power of 3 and c to the power of 3, because this exponent multiplied with 1 is going to be 3, and then it's also going to multiply with 1 of c, and that's going to be 3. So now if you just put the 6 cubed in your calculator, you will find that the answer is 216, and you just have c cubed. So that is how you will do that example. So can you please pause the video and try to do the following example. Let's say we have 5n to the power of 2 all raised to the power of 3. So the first thing is that you must note that if a number does not have an exponent, it has an exponent of 1. And then if you have the exponent outside the bracket, it will multiply with the exponent of everything inside the bracket. So this is going to be what? 5 to the power of 3, because the 3 will multiply with the 1. Then you're going to say n. Remember now, this exponent will multiply with the exponent. So 3 multiplied by 2 is going to be 6. So we are going to have 6 there. And therefore, we automatically know what? 5 to the power of 3 is just going to give us 125, and therefore we have n to the power of 6. So that will be the answer to the problem. So now, please note that if you have two numbers inside the bracket, you are not going to do that law. This law only applies if what is inside the bracket is a product. So that means it is one term. So let's say you have now m plus n all to the power of x. You can't say the answer will be what? Will be m to the power of x plus n to the power of x. This will be totally incorrect, because this law here only applies if you have a product, if you have multiplication or division. If you have multiplication or division, we consider that a one term. So now, let's say, for example, we have a division. So if we have a division, this is going to work. So let's say we have a over b all to the power of m. So remember, we already know that any number is to the exponent of 1 if it does not have any exponent. So the outside exponent will multiply with the exponent of everything inside. So now you're just going to say this is going to be a to the power of m all divided by b to the power of m. because the m will multiply with 1 here and the m will multiply with 1 there. And therefore, that is going to be the answer. So now, can you pause the video and try the following? Let's say we have b to the power of n all divided by c to the power of 2, and then we have all these raised to the power of 3. So now what we're going to do is that we're going to say, okay, inside here we are just having one number, because if we have multiplication and division, we are just having one number. But if we have plus or subtraction, we can't use this law. Please remember that. So now we are just having one number. So you're going to say what is outside here will multiply with the exponent of every number inside that bracket. So the top and the bottom. So the answer that we get is going to be what? We're going to say b to the power of what? Remember, the 3 will multiply with the n, and it's just going to be to the power of 3n. All divided by what? The 3 will multiply with the 2, so the c will be to the power of 6, because 3 multiplied by 2, that is 6. So now that is all that we need to know about the third law. So everything inside the bracket multiplies with the exponent of everything that is outside the bracket. So now, what does the fourth law say? The fourth law, it says what? It says that if you have a negative exponent, that means it is a reciprocal. It is an inverse. So let me show you something. Let's say we have a to the power of -1. So a to the power of -1, we can just simply write it as what? As 1 over a to the power of 1. So now, if the exponent is negative and then is at the top, so remember now this is just over 1 here. We're just going to move that number with the negative exponent and put it at the denominator, but now change the exponent to be positive. Okay? The same thing will happen if that negative number was at the denominator. We're going to move it up and change the sign of the exponent. So now, let's say, for example, we have the following problem to simplify. Let's say we have 2 to the power of -2 all divided by 3 to the power of 2. So now, what we see is that we have this negative exponent at the top. So that means the negative exponent, it must come what? It must come at the bottom. But now it will change the sign of the exponent. So this will be what? What are we going to remain with at the top? We're going to remain with nothing, which is just going to be 1 all divided by what? At the bottom, we're just having 3 to the power of 2. So now the 2, which is to the power of -2, is going to come down now and change the sign of the exponent. So it's going to be 2 to the power of 2. And therefore, we can just simplify this to say now we have 1 over 3 squared is 9, and then 2 squared is 4. So this will just simplify to be 9 multiplied by 4, which is just going to be 1 over 36. That is how you will solve that problem. So now, let's say, for example, we are having this problem here. 5 all divided by 3. Let me just say 4 multiplied by 2 to the power of -3. So now, how will you simplify this problem? You're going to check, okay, I'm having this negative exponent that is below what? Below the fraction. So I will take it at the top. But now remember, when you take it at the top, the sign of the exponent is going to change. So at the top, you are having 5. So you still want to write what you have at the top, which is 5 here. And then you're going to do what? You're going to move that 2 up there. So the 2 will multiply, but it's going to be what? It's going to be positive exponent, because it has moved down. When it moves down and it gets up, it's going to be what? It's going to be positive. And then at the bottom, we are still remaining with just 4. So now to simplify this, we're just going to say, okay, this is 5 multiplied by what? What is 2 cubed? 2 cubed is just 8, all divided by 4. And then the 4 will cancel out with, 8 divided by 4 is just going to be 2 there. So what is just left is just going to be what? It's just going to be 5 multiplied by 2, which is just going to be 10. But remember, you can just put that on your calculator after you have simplified to get the final answer. So the final answer here that we get is 10. But if they say without the use of a calculator, you need to know how to work that out. Okay? So that is how we use that inverse law. So the inverse law, it works like that. If you move something negative up, something with the negative exponent up is going to be positive. If you move something with the what? With the positive exponent down, is going to be negative. Same thing like that. So now let's say we have this following problem here. We have a to the power of 2 all divided by a to the power of negative 1. So now what we are going to do is that we're going to say, okay, now this negative 1 here, we can just put it at the top. So this will be the same thing as what? As a to the power of 2 multiplied with a to the power of positive 1. Because if it moves up, it's just going to be positive. It changes the sign. So remember, at the bottom here, you are now left with nothing. You can just leave nothing there, or you can just say over 1. So now at the top, you're just going to have a cubed, a squared multiplied by a to the power of 1, which is just going to be a cubed. Because if you multiply same basis, you add the exponents. So the answer will just be a cubed. So now let us look at the fifth law. The fifth law, which will simplify this further. So now the fifth law says what? If you divide numbers with the same base, you subtract the exponents. So now if you have what? If you have m to the power of n all divided by m to the power of x, what you're going to do is that you're going to do what? You are going to say, okay, I'm dividing the same numbers with the same base. So I'm going to keep the base the same and I'm going to subtract the exponent. So you always start with the exponent at the top. So you're going to have what? You're going to have n minus x. So that will be the solution to the problem. So every time when you are doing what? When you are just dividing numbers with the same base, you just keep the base the same and you subtract the exponents. So now let us look at the same example that we did previously when we did the inverse. If we have a to the power of 2 all divided by a to the power of negative 1. So now we can see now we are dividing what? Numbers with what? With the same base. So we're going to do what? We're going to keep the base the same. But what we're going to do, we're going to subtract the exponent. So now you start with the exponent at the top. This is 2 here. Then you have subtract. But now the exponent at the bottom is negative 1. So this is going to be minus 1. So you will see that the answer that you get is still going to be a to the power of 3. Because the negative and negative will become a positive. And 2 plus 1 is going to be 3. So you see now this one here, it simplifies when you divide. This law of the fifth law. So now let us look at this example here. Let's say we have x, let me use a different color, x to the power, just x to the and then y negative 3, all divided by x to the power of 4, and we just have y there. So now what we do is that we can see now, okay, we have the same basis that are dividing and the same basis that are dividing. So now we're going to start with what? With the base of x. Remember now the base of x, the exponent here is 1. So we're going to say, okay, because we are dividing, we're going to subtract the exponent. So we're going to say, okay, we keep the base the same. But now the exponent that start is the one that is at the top. So we're just going to say you have the exponent of 1 minus him with the exponent at the bottom, which is 4. Then you're going to say, I'm done with that part. So you're going to put multiplication and go to the second part here, which is y. So you're going to say the base is y. But now the first exponent, which is at the top, is going to be minus 3. And the exponent at the bottom is just 1 there. So you're going to say minus 1. And therefore now, if you simplify this, you're going to say x, 1 minus 4, that is going to be minus 3, multiplied by what? If you have minus 3 minus 1, that is going to be minus 4. And that will be the answer to your problem. But now remember, if you have negative exponents, you can just write this as positive exponents by doing what? By making them an inverse. So you're going to say what? Okay, I'm going to move these things down here. So now at the top, I will be left with 1 because both of them, they will move down. So now this x was having a negative sign at the top, so it will have the positive sign if it comes to the bottom. And then the same thing as y. When y comes to the bottom, it's going to have the positive sign because it had the negative sign. And therefore, this expression, it is left with a positive exponent. So that is what you need to know about the laws of exponents. But now on the next video, we're going to look at different applications. For example, where we have to expand, subtract, take out a common factor, a lot of things. So now, thank you for now, but I will see you on the next video. Bye-bye.